Well, hello there, everyone, and good evening, good morning, and possibly good night for most people. My name is Audrey Codner, and I'm the owner of ACG Math Tutoring. And I have been coming on live a couple of times during the day, so I just figured, you know what? Let's try at nighttime. Let's kind of cool down and get to do some math. Yeah, it says no one, but you never know. We have some people that are night owls, night birds, and they might want to kind of get to know how to do a little bit of math. So what I am working on tonight is the types of polynomials. So we're looking at the types of polynomials, and we're going to see if we do some adding and subtracting of those said polynomials. So what is a polynomial? Everyone talks about these things. So a polynomial is a representative of more or one terms, and it's usually separated by addition or subtraction. So if you're wondering what a term is, if you take a look up here, we have 3x squared plus 4x minus 9. And the 3x squared is being separated by a plus sign. The 4x is being, and the 9 is being separated by a minus sign. So we actually have 1, 2, 3 terms. Even the number that doesn't have an x next to it, that's called a constant. And with our constants, they're part of the term. So here we have 3 terms. So the type of terms, when it comes down, you either have a monomial, a binomial, trinomial, or a polynomial. I'm going to see if I can make this a little bit bigger so we can see what's going on. So a monomial, that's considered a one term. So one term, an example will be like 3x. Okay, that's considered one term. It's not being added or subtracted by anything. A binomial, hence the word bi, mon, that's 2 terms. Hey guys, welcome in, way to come in. So 2 terms, that's being separated by a plus and minus. So if I say 2x minus 1, that's a binomial because it's having 2 terms. Trinomial, let's take a wild stab here. We got 3 terms. So 3 terms, a trinomial is just like my example that I have up here. My 3x squared plus 4x minus 9, there's 3 terms, so it's a trinomial. And then a polynomial, it's going to be more than 3 terms. So if I said 4x to the third minus 6x squared plus 7x minus 11. This is a polynomial. Even though it's 4 terms, it's still considered a polynomial. So we got my 4x cubed, that's 1 term, 6x squared, that's another term, 7x, that's another term, and 11, that's another term. So anything more than 3 is considered a polynomial. So with this being in mind, we like to have our polynomials. If you haven't noticed, I always have something at a high degree. So a degree is an exponent. So if you think about it, like if I said, it's 75 degrees outside, which it is not here in Baltimore. It's actually snowing. So I just want to say hello to a couple people. Hello. All right. Notice the degree symbol is right where the exponent is. Okay. So I'm going to slide this over a little bit just so you can see. So now that we have the degree symbol, that's in the same spot as an exponent. So we call the exponent an actual degree. So with this degree, comes another term. The other one is called a leading coefficient. So if I may, I'm going to use my 4x cubed minus 6x squared plus 7x minus 11. My highest degree is my highest exponent, which is to the third power. The coefficient, which is usually the number that's in front of the variable, that with the highest degree is called my leading coefficient. So the coefficient is the number that's in front of the variable, but the leading coefficient is the one with the highest degree. All right. So as we're kind of doing a little bit of the adding and subtracting, we always want to start with the highest degree and then work our way down in descending order. So right here we have with the cube, then we're going to the square, then we're going to the first, and then we have the constant. So what we're going to do to kind of solidify all this is I'm going to have us add or subtract some polynomials. So let's get to it. So if I said so with my first example, say that I have negative 11 plus n to the fourth plus 3n. So what do you think is my highest degree? This one doesn't have an exponent. This one does, which was 4, and this one has to the first. So my highest degree or my highest exponent is going to be to the fourth. So that means the coefficient or the number that's in front of that n is going to be my leading coefficient. So if you don't see a number there, it's always assumed that it is going to be a 1. So I'm going to say my LC or my leading coefficient is going to be 1, and it has my highest degree, which is 4. Hey, Kimmy. A couple people popping in. All right, so do not be afraid of the math. If you are here, go ahead and share the live if you want to, or maybe even tap the screen. Give me a little bit of love. That would be so amazing. And I know a lot of people are like, it's almost 8:45, Audrey. Like, I'm done. Well, I've been tutoring most of the day, and I had meetings. So trust me, I am really done. But I really wanted to share this out, especially with people that are thinking about taking their GED, or if they're thinking about going to take the ASVAT for they can go to the military, or they're going to take the AccuPlacer if they want to go to community college. They're going to have these type of questions on those tests. So I like to share my knowledge of how to break these things down so when it's time for you to take the test, you're not going to be overwhelmed. You're not going to be stressed out. So knowing my leading coefficient, everyone will assume that it's always in front, but it's not. It's always the one with the highest degree, and then the number in front of that variable will be your leading coefficient, your LC. All right? So if I say we have 1, 2, 3 terms, so that means this is a trinomial. So if I give you, let's go with another example. I'm going to make it a little bit bigger. And then we have, let's say, 8x minus 4 minus 7x cubed plus 3x squared. So taking a look at this one, we have 1, 2, 3, 4 terms. So that means it is a polynomial, because anything that is more than 3 terms is considered a polynomial. So knowing that it's a polynomial, so now we need to see what is my highest degree. Where is my highest exponent? My highest exponent is right here with the cube. So if that's my highest exponent, that means the number in front is going to be my leading coefficient. Now, this is where a lot of people get screwed up. They'll just say, oh, my leading coefficient is going to be 7. But this minus sign also acts as a negative. So it's actually going to be a leading coefficient of a negative 7. So my degree is my highest exponent, which is 3, and my leading coefficient is a negative 7. Hi, yeah, I'm back again. So this is how you basically categorize, like look at the different types of polynomials. It has 1, 2, 3, 4 terms, so it's a polynomial. My highest degree is my highest exponent, which is to the 3rd power. So that means the coefficient that's in front of the variable, including its sign, will be what's called my leading coefficient. So if I do, let me see if I can do one more very similar to that, and then I'm going to try to teach you how to add these bad boys together. Okay, it's okay. It's going to be all right. So if we have 4x cubed plus x to the 5th. So taking a look at this, how many terms do you see? Okay, if you want to put it in the chat, how many terms do we see? So we have one that's right here, which is the 4x cubed. It's being separated by a plus sign, and then this is the other one. So we have 2 terms here. Okay, so if it's 2 terms, this is called a binomial. Okay, so if it's 2 terms, it's called a binomial. So we have a binomial. Now, what is my highest degree? That's going to be based off of the exponent. So we have a cube and we have to the 5th power. Which is bigger? The 5th power. So since this is my highest degree, that means the number in front of the variable, including its sign, is going to be my leading coefficient, my LC. So if we don't see a number there, it's assumed that it is a 1. All right? So binomial, 2 terms, highest degree is to the 5th. And my LC, or my leading coefficient, is right in front of that variable with its sign, so it's going to be a positive 1, or just 1. All right? So that's how you figure out the different types of polynomials. So if we're here, if you show a little love, type on the screen, I would greatly appreciate it. If you actually like what's going on, like what's being played, just let me know. I tried to play like a little bit of background music, try to relax, because I know when it comes to math, students generally are freaked out. Parents are freaked out because they went through the whole trenches and they were like, I don't like it, I never understood it. kids kind of do a reflection of their parents. So when it comes to math, I'm the type of person that I like to take things step by step and just really absorb and really understand what's going on. That's the problem with a lot of times with the classrooms. They're not allowing the teachers to actually have these kids have time to let this information marinate. All you know is like everything is happening so quickly, and then it's overwhelming, and then they shut down, and then that's it. But my thing is, there is no escaping of math, okay? Really thinking about how to make decisions, that's a mathematical problem. Really how to break things down. Music, that's math, that's sine, that's cosine, that's sometimes tangent when it comes to the sine waves. Is looking at like the different forms, how we communicate, how we fluctuate with our voice and our tone, how we have our accents. All of that is math. So math is its own entity. So with that in mind, we are going into adding these polynomials, okay? So we're going to try to add these together. And the key thing that you have to understand, you're basically playing a matching game. So if I can, when it comes to formulas, I'm going to write adding. So adding and subtracting. You're basically playing a matching game. So you're going to match x squares with x squares. You're going to match x's with x's. Like that's basically what you're doing. And then you're using the operation to solve. So if I may, let's go with the very first one. So if I'm adding, all you're doing is combining. What they like to say is combining like terms. Okay, so I'm going to add these polynomials. So if I have 4x plus 5 minus 11x. So this is a problem that one of my students was having problems with. So if you notice, there is no equal sign. So we're not, hey, how are you? We are not solving it. All we're doing what's called is simplifying it. We're trying to combine our x's with our x's and our y's with our y's. That's all we're doing. So if we take a look, we have a 4x and we have a negative 11x. Okay, we got to take the sign. I know it says subtraction, but sometimes your subtraction sign acts as a negative sign. So here's the thing when it comes to positive and negatives, all right? So when you are adding and the signs are different, your answer is always going to be negative, okay? You're always going to be subtracting. So with that in mind, we have 4x, which is positive because there's no minus sign in to the left of the number, but then minus 11. So think of it this way. I have $4. I want to buy something that costs $11. So that means I'm short money. I only have $4, but I want to buy something that's 11. So how much am I short? I'm going to be short $7. And I bring the X with it because the X is the item that I'm basically trying to buy. So these are like terms because 4 has an X and the negative 11 also has an X. So I can combine those two. But when it comes to this plus 5, hey, I don't really have anything to combine it with. So if I can't break it down or combine it with something, I'm bringing it down. So the answer for 4x plus 5 minus 11x is going to be a negative 7x plus 5. And I can't combine these two because that 5 doesn't have an x. So they're not like terms. They're not matching. So it's like having that memorization game that we had years ago where you had to flip the card. It was like memory. You have an apple and then you flip it. You got to add pineapple. And you're like, nope, that can't match. But if I flip an apple and I flip another apple, all right, good. I get to keep those. Those are points for me because I matched the correct ones. So you want to match apples with apples, oranges with oranges. Let's try another one. Let's see if I put it in pen. So if I have 18y minus 5 plus 2y. So I have two sets of y's. I have one that's a positive 18y, and that matches with this positive 2y. So those are like terms. So I can go ahead and combine those two. 18 plus 2, that gives me 20. So I write my 20 and the y. So now what comes down is my minus 5. Thank you for the love. I greatly appreciate it. Oh, I got my little gift. So then my minus 5, I'm going to bring down the minus 5. Now, I can't combine these two. The reason why, the 20 has a y and the 5 doesn't. So they're not like terms. That's how I know when I get to stop, when I don't have any more like terms to deal with. Okay? So how are we feeling? All right, let's do one more. And let's kind of challenge ourselves just a little bit. So if I have 3 minus 4x minus 8 minus 5x. So with this, we're trying to combine like terms. So if we take a look, what are my like terms? So we have a negative 4x, and that matches with a negative 5x. The reason why these two matches, because they both have an x. They're basically a pair. So now, what's different this time, I have a positive 3 and a negative 8. They both don't have a variable. They don't have an x or y. And that's perfectly fine. That means I can combine those two. So that's how we kind of extended it. So let's take a look. Negative 4 minus 5. They both have the same signs. They're both negative. So when the signs are exactly the same, you're going to add your numbers. So 4 plus 5, that gives me 9x. All right, so when the signs are the same, you add the numbers. But when the signs are different, just like what we have with 3 minus 8, we're actually going to subtract. So 3 minus 8, that will give me a negative 5. All right, so that will give me my negative 5. Now here, I have negative 9x minus 5. And you're probably saying, well, how do I get the negative 5? Well, if I have $3 and I want to buy something that's $8, that means I am short $5. I need to borrow $5 so I can pay for it, right? So if you think of it as money, sometimes it's not as threatening. It kind of like eases it a little bit. Now you get to see it happening and perform right in front of your eyes. So when you're combining polynomials, okay, even though we have positives and negatives, this is a combination of adding and a little bit of subtracting. But if you just remember, when you're combining and the signs are the same, you add the numbers. Keep the sign. That's why it's a negative 9x. The signs are different, we're going to subtract. When we subtract, give the answer the sign of your largest number. Don't think of this as negative 8, just think of it as 8 that is actually being subtracted. All right? So, if you are liking these, if you want to follow me, go ahead and give me a follow. I would love that. If you ever have questions and you want me to kind of expand on these, I am more than willing to do so. Okay? Now, let's see if I can take this up a little bit more, right? Let's just take it up. So, if I want to, first of all, let me go right here. This will be great. So if I have 12x, I'm going to put it over here. Let's see if I got some room. There we go. So we have 12x plus 7x, okay, minus 7x plus 5. All right, so 12x plus 7x minus 7x plus 5. First off, what kind of polynomial is this? So is it a monomial? Is it a binomial, which is 2 terms? Is it a trinomial, which is 3 terms? Or is it a polynomial, which is more than 3 terms? All right, Claudia, thank you for the follow. I appreciate it. So when we take a look, we have 1, it's being separated by a plus sign, 2, being separated by a minus sign, 3, being separated by a plus sign, 4. So we got 1, 2, 3, 4 terms. So this is a polynomial. Anything that is more than 3 terms, I can have this thing going from point A all the way over from here to the end of my paper if I want to. I can go from side to side. If it's more than 3 terms, it's a polynomial. So now, let's play the matching game. So we have 12x, we have 7x, we have 7x or a negative 7x. All of these x's, they can be combined. So if we want to combine them, we're going to work from left to right. Okay? This is the thing about, please excuse my dear Aunt Sally. This is the part that screws a lot of people up. They always forget to go from left to right. So if we want, we can say 12x plus 7x. So if I combine those two, what's 12 plus 7? Hopefully you're telling me it's 19x. Then you just bring everything down. The minus 7x and the plus 5. So now we want to combine the other like terms, which is my 19 and the minus 7. Well, 19x minus 7x, that gives me 12x. And then what's left is my plus 5. Now, we might have a couple people in here that'll be like, hey, Audrey, we could have taken that step a lot quicker. I'm like, of course we could have. If you look, if I have a positive 7x and a negative 7x, yes, I could combine these two. Because that's going to give me a big whopping 0. Now, because they cancel out, the x's don't hang out. That means the x's are gone. All right. So if I have this pencil and then I want to take it away, is there a pencil still here? If so, might want to ease up on the drinking a little bit. Okay. So there's no pencil. Okay. It's completely gone. So it's not saying, oh, I have 0 pencils. You just don't have anything at all. 0 is a placeholder. And if we don't need the placeholder, just take it, then just get rid of it. Okay. And we could have just eliminated those two to bring us right to that 12x. So as you feel comfortable with it, you're going to see these little shortcuts. And especially it's great when you have these assessments that you really want to make sure that you keep those things in mind. So now here's the kicker. Can I combine 12x with 5? I cannot. Because the 12 has an x, the 5 does not. And since they don't, that's my final answer. All right. So we're just really trying to take it step by step. If you know anybody else that needs a little bit of assistance with this, please have them come on in. All right. So really want to kind of get, all you're doing is playing the matching game. And you really need to understand what your rules of integers are. All right. So if you ever get stuck, all right. So this is the one thing I love about this notebook. So this notebook I actually designed for my tutoring students because I totally got sick and tired of seeing notes like this from my tutoring kids. Like sometimes I felt like I was going crazy. They would copy all this information down, but then this is the problem. I would ask them, what does your note say? And they can never answer the question. Never. So it's almost like this is what's happening in our classrooms. Like the teacher will have like a bunch of notes. If you want your teacher is the type of person that wants you to copy things off the board, the kids will write down example, they'll write this down, and then they'll stop writing, have to look up at the board. Then they come back to the paper, write down a couple of things, look up at the board, and next thing you know, everything is being erased. They didn't get enough time to write things down and then have the teacher say, this is what you just wrote down. And let me explain where this is coming from. Then, all right, I want you to copy this part down. So they'll copy this part down. All right, what you guys just copied down was this, and break down what exactly they're copying. Because then you're giving the brain time to basically adjust and to absorb exactly what you're learning. So with that in mind, kids nowadays are writing down notes, but they're not looking back at their notes when it's time for them to study. Because a lot of kids will do exactly this. They will take their notes and they will just flip through pages. Okay, they're like, yeah, I got that. Yeah, that's great. This is wonderful. Nice. Okay, yeah, I remember this graph. All right, and that. Guys, that's not how you study. That's not how you study in math, especially. So say, for instance, they want to do like a math problem like this from their notes. What they'll do is get a sheet of paper, copy down the problem. After they copy down the problem on their sheet of paper, blah, blah, blah. Okay, Then they're going to take their notes away. Now on that separate sheet of paper, they're going to solve out the problems. They're going to write everything out. They're going to solve it out until they get to their final answer, right? Once they get to a final answer, they're going to bring the notes back and they're going to compare what they got on the paper with the notes, the answer from their notes. They're using their notes as an answer key. So by you using your notes as an answer key, it's kind of like, oh, well, what did I do wrong on my paper? Because I got 6, but in my note says 37. Yeah, that's a huge difference, right? So then you want to retract and go back to what you did and then follow step by step from the notes and do a comparison. So when you do a comparison, you're like, oh, I forgot the negative. I should have subtracted the 3y instead of blah, blah, blah. That's how you study with math. You have to really learn and to break some of these concepts down that way. Now, I know there's a lot of people that are just like, all right, well, I kind of like your notebook, how it's designed. The reason why I have it designed like this, it's like Cornell notes. I like to have a section for where the students can write the formulas, if there is a formula. So there are sometimes there isn't a formula, sometimes there is, and it's such a quick reference that the kids can just jump straight to it whenever they have, say, an open notes quiz, or they just really want to get the problem or the formula in order to solve a particular problem, as well as step by step. Because if you get a kid that's trying, or even an adult, like after you had a full day, you went to class, you come home, you get your family situated, and then you come to sit down to do math, and you're like, how did I do this again? And then you're sifting through papers and packets, and you just don't know where the answer is, and you wish someone just put it in a particular spot. Here it is, okay? You have your formula, and you have your steps that you need to take in order to solve. And then in this section, you basically have examples. How did you do it? How are you going to process it? Now, this section up here, let me slide that down. This is the mood tracker. So I know, like, when my students, when they first come into the classroom, I'll ask them how they're doing, and they can say fine, because that's what teenagers do. But all they have to do is just circle. I don't have to interject in their lives. I don't have to make them feel any type of way. So once they circle it, then during the session or during the lessons, you can ask, all right, guys, just circle. How you guys feeling with the lesson? What's going on? All they have to do is circle. And then after they circle, then at the end, you can ask them, hey, how was this session? How did you feel that you did with this lesson? Are you feeling okay with it? What's going on? And then they can circle how they're feeling. So this works great for like homeschool parents that's having their kids doing their collab or their curriculum. This is great for classroom teachers. So, admin always asks you, how do you know your kids are learning? Now you can say, well, I kind of look at that mood tracker, because no one likes to do the thumbs up, thumbs down anymore. Because a lot of kids are going to say thumbs up because they don't want to be called out that way. All right. So in addition to this, I know we didn't do too much with it, but if I get stuck and I don't remember the rules of integers, I have what's called a resource page. So this is my factor sheet. So if you're ever doing multiplication, because guess what, guys? Our kids do not know how to do multiplication whatsoever. So then, but here's my rules of integers, okay? These are the rules when you're adding, and I'm giving you examples of those adding. Then also subtraction. I give you examples of subtraction. What does it look like? Even with the parentheses, what does it look like? And then the rules for multiplication and division. So we're all taking a look. This is what I use for like my reminders. So for word problems, I generally like to use this form here. This is the most used words in most word problems. So words that represents addition, subtraction, multiplying, division, equals, and inequalities. This one is a game changer right here, all right? Because a lot of students always gets this wrong. They confuse is more than with more than. More than is addition. Is more than is an inequality. Same thing with less than. Less than is subtraction. Is less than is an inequality. So just because of that word is changes it from either addition or subtraction to an inequality. So this particular book is designed for 7th through adults. So those people that are going back to school, looking at the different properties of exponents. Anything raised to the 0 power is not 0. It is 1. It has to start somewhere. So some kids will forget, but at least they'll have this reference to hold on to it. Then it starts getting a little bit technical. Okay, it gets a little bit with the technicality. Can't even speak. So you have your Pythagorean theorem. Remember, a squared plus b squared equals c squared? If you don't, it's in the book. All right. Then you have your SOHCAHTOA, your sine, your cosine, your tangent. So all your kids that are doing Algebra 2, this is going to help them out. Or even if they're doing geometry, these are always going to help them out. This is when it starts getting advanced. As you can see, I have some more stuff that I want to add into this book. But this is when it gets more advanced, especially with the advanced geometry and also advanced algebra 2. And I also am starting to see it in my AP pre-calculus as well. So just before we do sine waves and all that, cosine waves. Then we have a little bit more with the geometry. We have our total surface area, we have our surface area, our volume of the different three-dimensional figures. We're talking about circles, we're talking about sectors and some arc length. And then the piece de resistance, the unit circle, okay? Every kid that's taking Algebra 2 and pre-calculus is going to experience the unit circle in one way, shape, or form. Some of the kids have to memorize the coordinates of our points. Some of them can't really remember. So I have like a table that kind of helps breaks down what is the value of the degrees in radians of your sine through their inverses. But just like most, one thing I like about this book is the brain breaks. Everyone needs a moment, right? So why not have like a word search, do a maze, Sudoku, maybe even take one of your areas that you just want to color over and over again. Do a little bit of light shading, okay? You can sit here and that gives your brain a moment to refocus. A lot of people generally don't think about that. And then if you have students that are into pixel art, there's some space for them to do pixel art and also to do a little bit of sketching, okay? Might be a sketch of their favorite teacher. Maybe that might be it. All right. So this is my math notebook. As you can see, I hold on to a lot of different concepts that is usually being touched in Algebra 1 and Algebra 2. And if you want to purchase your own, you can actually purchase this on Amazon. Yeah, I put it on Amazon. So I have this. I have 2 other covers that are like this. As well as, if you're thinking, well, I got little ones. I don't really have anybody in the 7th grade. That's okay. I got you. We got one for 4th and 6th grades. So what I do differently with them is I have some math tiles to kind of help them get their numbers in order. If you have a student that is like saying, okay, I have 573 and I want to subtract 94. Notice I can put them in their slots, okay? You put the numbers inside of their own blocks. By doing so, now I'm saying, okay, this is going to be my ones column. And you can actually label. Here's my ones, here's my tens, here's my hundreds. Okay? So then you go into the whole, let me borrow from the tens. So I make this into a 6 to make this 1, that 3 into a 13. Okay? So when we're doing that, now, oops, kind of got a little crazy there. I'm trying to say hi to people, but my apparatus is not allowing me to do that one. Sorry. So now we're trying to figure out, okay, so I have 13 minus 4. So with 13 minus 4, I'm going to have 9. So I'm putting my 9 down here. Now, can I do 6 minus 9? No, I need to borrow. So now that 5 is now a 4, and it's in its own block. And now instead of a 6, it's a 16. So if we have 16 minus 9, that gives me 7. And then the 4 just comes down because 4 minus 0 gives me 4. So now they can look at the ones, the tens, the hundreds. Now, if you want them to do rounding, I want you to round to the hundreds, to the nearest hundreds. That means you need to look at the 10th spot. So once you look at the 10 spot, if it's 5 and above, we give it a shove. If it's 4 and below, we leave it alone. So it's more than 5, so that means I'm going to be adding 1 to this next digit. So it'll be approximately, that's what this wave stands for, approximately 500 if I wanted to round to the nearest hundreds. So things like this, if there's a formula that needs to be dealt with, that goes in here. If there are steps that you want the kids to take, sometimes I've seen teachers that will break it down and then have the students write down steps and make sure they get it clarified from the teacher to make sure that they're learning it the right way. Giving the kids some ownership. Yeah, giving them a little bit of, hey, you can definitely do this. All right. So thank you so much, guys, for being in here. I greatly appreciate it. If you want, you can go ahead and follow. If you want to tap the screen, you can go ahead and tap the screen. I would love that. Give it a little double taps. All right. But I just like to have organization. I like when students are really taking ownership and just really absorbing what's going on. So like I said before, they have their befores. Thank you so much. So they have their before the lesson, how they're feeling, during, and after. But as you can tell, we're not going to go into the whole unit circle and everything like that. So we have like 100 of these pages. Okay. The other side from the guided notes is exactly the same thing, giving kids more room to put things in. If a teacher wants them to put a paper inside their notes, they can tape it in and then have the students summarize what's on that paper on this side of the page. So after you go through like the 100 pages that I have here, I also have a resource. Here it is. Resource page. Again, they have my factor sheet just like the other one. I don't just go from 1 to 100. I actually go to 1 to 200. So helping those kids out, trying to figure out the factors or just figuring out what two numbers will be multiplying to help them break down articles, as well as fractions. What is a fraction? You got the definition of a fraction. You're looking at the parts of it, the numerator and denominator. Give you some examples, as well as additional examples with representation. Over here, if you want to do activities, groups of 4, groups of 5, groups of 6s. There's 5 over here, 6 on the other side. Okay, so they can actually take Skittles. And you can put Skittles in each of the sections so you can work on the fractions. Or you can take grains of rice and they can actually put a grain on each of the circles so they can see how close are they to a whole number. The other part, especially from the 4th through 6th, I know there's a lot of conversions. In 4th through 6th grade, they do tons of conversions. So we have all that. Factors, operations, as well as place values, decimal operations. We have conversion charts. You still have the same properties of exponents, areas, and perimeter. Okay, volume. So very much the same as the other book with some exceptions. Okay, again with the brain breaks, a little bit different from their book. This book is a lot smaller, or a little bit smaller than the other one, but it still packs a powerful punch. Okay, so if I line it up, you can see that there's definitely a little bit more room. This is 8 by 11. This is 8 by 10. All right. So basically dealing with the adding and subtracting, I really just want you to understand that anytime that you are adding or subtracting polynomials, you make sure you remind yourself that all you're doing is playing a matching game. X's with X's, Y's with Y's, constants with constants. All right. So I will be here. I come live at 1:15. I think that's what I have. 1:30 in the afternoon, or no, sorry, 1:15 in the afternoon. But I'm also going to start coming later on in the evening around 8:30. Just to kind of show a little bit more. And I'm thinking tomorrow night I'm going to work more on the multiplying so I can talk to you more about the factors. So we did adding, subtracting. So tomorrow night I'm going to work on multiplying. But if there is something that maybe you're currently doing a GED class, or you're currently doing a class yourself and you want some assistance with something, go ahead and message me like what the content is. Maybe you could take a picture of it and then share it with me. And then I can actually go live here on TikTok. And I only do this on TikTok to break down these concepts. So, all right. So I would love for you guys to have a great evening, a great morning, and a great day. And please continue to be awesome and keep wanting to learn. I think you guys are going to be amazing. All right. Have a lovely evening, and I will talk to you later. Bye.